In this video series, I want to give you a brief overview about key characteristics that we discuss in pharmacokinetics. So what does pharmacokinetics mean? Well, pharmaco comes from drug, and kinetics is the movement. So it really describes the movements of the drug through the body. So far, we have discussed a lot about drug effects, and that's what usually is discussed within pharmacodynamics. So pharmacodynamics stands for pharmacodrugs, and dynamic is Greek, means power. We can think about it like an effect. So it means the effect of a drug on the body, so that we usually think about when we say this drug acts at a certain receptor and has a specific effect. So that's what pharmacodynamics is about. We can summarize it really as, what does the drug do to the body? In contrast, pharmacokinetics means, what does the body do to the drug as the drug travels through the body? When we are thinking about pharmacokinetics, we usually think about a couple of key characteristics, and they're a lot of times abbreviated as ADME. And this stands for absorption, distribution, metabolism, and excretion. And these are the ADMEs. Because if you think about it, that really describes how the drug is traveling through the body. First, the drug needs to be absorbed. Then it's going to be distributed in the body. The body's going to work on it. It's going to be metabolized. And then it's going to be excreted. A lot of times when we study pharmacokinetics, we will look at concentration time curves. So usually we look at the concentration of the drug in plasma, which we call CP, and then over time. And so how would that look like? Well, depending on how the drug is administered. So let's suppose you're going to inject a drug into a patient. So it's going to rise like very quickly, and then it's going to slowly be eliminated from the body, for example. If you take a drug orally, well, it's going to be measured in the plasma, so that CP, concentration in the plasma, it will take a little bit to get into the plasma, and will probably not reach the same peak, and then slowly level off. So that would be an example for a orally administered drug, POs, or this would be an example for an IV administered drug. And please note that the time that you need to reach the peak concentration is obviously faster. In an IV drug, it's always the fastest compared to an oral administered drug.